For this problem, we're going to use our graphing utility to determine the local maxima and local minima of a function. Then we'll use those values to determine where the function is increasing or decreasing. We're going to be graphing the function f of x equals negative x to the fourth power plus 2x cubed plus 4x squared minus 2. We're going to graph on the interval negative 5 to 5. We're going to approximate local maxima and local minima and then determine where the function is increasing and where it's decreasing. To do this, we're going to enter our function in for y1 in our graphing calculator. So we'll go to our y equal to screen, clear out anything that might be in there. In y1, we're going to enter negative, make sure we use the negative key there, negative x to the fourth power plus 2x to the third power plus 4x squared minus 2. We'd like to graph that, take a look at what it looks like. We'll start with our standard window, just to give us a reference point. We know that we're only looking on the interval negative 5 to 5, that's for the x's, so we'll go to our window settings, and we're going to have to change that. We also want to see that our graph kind of barely misses the top of the graph. Our window settings barely miss the top, so we need to adjust our y max as well. So we're going to change our window settings here. Our x min we're going to put as negative 5 since it's our lower bound on our range for the x's. Then x max is going to be 5, so minus 5 to 5, that's the interval we're considering. We're going to let x scale be 1. Then for y min, we're just going to leave that at the negative 10. Y max, we do need to raise that up, so we're going to go ahead and go up to 20. Now the difference between the min and max is 30, so we're going to go a scale of 2 so that we don't get too many tick marks. We'll go ahead and graph that again, and so we get a little bit nicer graph. And we're looking for the maxima minima. Remember that maximums occur at peaks and minimums occur at valleys. The max and mins are the y values, so we're going to go ahead and find this using our calc menu. And we're going to start from the left side of our graph, which is going to be a maximum. So we go to our calc menu. We want to find a maximum, so we go down to option 4, click enter, and we get the question left bound. To get the left bound, we need to scroll to the left of that peak. We want to make sure we're clearly to the left of that, so we're going to be on the downward slope. Hit enter. Right bound, we want to go past the peak, make sure we're on the other downward slope, and we'll hit enter. And for our guess, we want to move up to the peak and hit enter. Now it says the maximum will occur when x is roughly negative 0.85. The actual maximum value is negative 0.86. The y value is the maximum. Next we see that there's a valley, so we're going to find a local minima. Go back to our calc menu. Scroll down to option 3 for minimum. We'll get the same questions, left bound. We want to make sure we're to the left of that valley. Hit enter. For the right bound, we want to be to the right of the valley. We'll hit enter. And then for our guess, we want to try to go to the bottom and hit enter. Here it says that the minimum will occur when x is 0, and the actual minimum value is y equals negative 2. Lastly, we need to find another maximum. So we go back to our calc menu, scroll down to number 4. We'll get our same questions, left bound, so we're going to go up a little bit here, but we want to be to the left of the peak, so we'll mark that point. Move to the right side for our right bound, and then for our guess we go to the peak. And so here we see that this maximum will occur when x is roughly 2.35, and the actual maximum value will be about 15.55. So here we're going to summarize the information we found from our calculator. We've got our function. We found that there was a local maximum at x equal to negative 0.85, and that maximum value was roughly negative 0.86. We found another maximum at x equal to 2.35. The maximum value was roughly 15.55. We also found a local minimum that occurred when x was 0. and the minimum value was -2. If we recall from our graph, the graph was initially increasing, so we're going to start from the left side. We're increasing starting at -5, and we increase until we get to that first maximum. That occurred at -0.85, so we know the function's increasing on this interval. Once we hit the maximum, the function started to decrease, so we're decreasing from -0.85, and we decrease until we hit the minimum. The minimum occurred at 0, and so we're decreasing on this interval. Once we hit the minimum, the function starts to increase again. So the function's increasing until it hits the next maximum. That occurred at 2.35. So the function is also increasing on this interval. Once we hit that maximum, the function started to decrease. And it continued to decrease until the end of our bound, which was at +5. So we have two intervals where the function was increasing and two intervals where the function was decreasing.